Hello everyone. We will continue our discussion on this velocity time graph. See, in last video, what we have discussed is area under the velocity time graph is equal to distance or magnitude of the displacement moved by the car in a given time interval. This is basic thumb rule that we are following, that under velocity time graph, the area under the line or area under the graph, area under the curve is nothing but the magnitude of the displacement. How it is that we have discussed in earlier videos, right? So now, as like in this uniform velocity, we have considered the point A and point B corresponding to the time t1 and time t2. Similarly, in this uniform accelerated motion where velocity is increasing, if I consider time t1 and time t2, and if I project a line from t1 and t2, from t1 I have drawn a perpendicular line. From T2, I have drawn a perpendicular line perpendicular to this time axis. If I draw a line perpendicular to this time axis from T1 or point B and from T2 or from point C, that line will intersect this velocity time graph at point A and point E. Now suppose for that case, it means when the object or the car has traveled from point A to point E, like here we have taken point A and point B for uniform velocity, and here we have said that area of this rectangle is nothing but the magnitude of the displacement. Similar logic here, if I apply, then this point A and this point E we want to consider corresponding to time t1 and time t2. Then the line AE, area under the line AE, will give us the magnitude of the displacement for the journey from point A to point E or during time t2 minus t1. Here is time t2 and here is time t1. So we want to find that particular magnitude of displacement. As we can see here, this trapezoidal area A, B, C, D, E, this area is nothing but the area below this line AE, or that area is in between this velocity time graph and this time axis. So that trapezoidal area, we just for our convenience, we will divide the trapezoidal area into two parts. First part is triangular area and second part is rectangular area. So first part is triangular area and second part is rectangular area. Rectangle ABCD and triangle AED. Right? Now, if the car moves with uniform velocity, distance traveled by car is equal to area ABCD under the graph. See here what we have said, that for the uniform velocity, the magnitude of displacement is nothing but the area of this rectangle. And we have considered the rectangle ABCD. Here that car was traveling with the uniform velocity of 40 km per hour. Now, same logic if I apply to this case, then here when the car travels from point A to point D, point A to point D, I'm not saying point A to E, I'm saying point A to point D. Here you can see when time was 10 seconds, velocity was 18 km per hour. When it is 15, still it is 18. When it is 20, still it is 18. So if I consider the line AD or the rectangular area ABCD here, then here that uniform velocity is maintained of 18 km per hour from journey point A to point D. Right? So this is the rectangle ABCD. So same thing it is written here. If the car moves with uniform velocity, distance traveled by the car. So to saying a rectangular area this or this, the meaning is the same, that here the car is traveling with a 40 km per hour, and here for the journey from A to D, the car is traveling with a uniform velocity of 18 km per hour. 18 km per. But actually, our journey is from point A to point E, corresponding to time t1 and t2, or for time duration or time interval t2 minus t1. So, to calculate that magnitude, what we need to do is what we need to do is we need to consider this total trapezoidal area, right? So that distance traveled by the car will be equal to A, B, C, D, E. So this trapezoidal area we need to calculate. How to calculate the trapezoidal area and to come up with the magnitude of displacement, we will discuss in next video. One more important thing about this diagram is, see, magnitude of velocity of car is changing due to the acceleration. So earlier we have discussed that if you want to bring change in velocity, there are three options. First, you need to change the speed, object speed. Second, you need to change the direction of the motion. And third thing is, togetherly, speed and direction you can change. Then you can bring the change in the velocity. So now here the velocity of the car is increasing. Here acceleration is constant, but in general, if you say whenever we will increase the speed, car will accelerate, right? And then the change in velocity or velocity will either increase or either velocity will decrease. Depends on whether we are increasing the speed of the car by accelerating the pedal or applying the brake. So depends on that increase on velocity or decrease in velocity, it will be dependent, right? So here to calculate the magnitude of the displacement for this uniform acceleration, we need to calculate the area, this trapezoidal area. So how to calculate that, we will discuss in next video. Thank you.